And basically what this is the reconstitution type of question that you might see at that they've been using at Boyce, South, and North campuses. We haven't really used it too much here at Allegheny campus, but I was told to at least show it to you because there's a potential you could see it on your test. I don't know if that's definitive or not, but just figured I'd let you know so that way you can be prepared. So let me just go over the specifics on this. And then, like I said, if you have other questions, then we'll address those. So I haven't created a separate question for this just yet. So this is just a sample. And basically what this is a reconstitution question. A reconstitution just means it's powder. When it's in the pharmacy, it's in a powderized form. They add water to it, they mix it up, and then that becomes active and ready for, in this instance, injection. Now, typically when you have like your parenteral medications or even your oral-based liquid medications, it usually gives you a strength associated with it, or concentration associated with it. And as an example, you might get something that says like, look for an example here that's similar. Yeah, like this furosemide. So it tells you that it's available at 30 milligrams per milliliter. So you know what its concentration is. Technically, this furosemide, without giving you the label, is an example of a reconstitution question. It's just that you haven't been asked to do it. Same thing with this, or similar, where Decadron is 25 milligrams per milliliter. So you know what the strength is, or heparin is 5,000 units per milliliter. You know what the strength is. When we come down to this question, oops, come up, sorry, forgot where I put this. When you come up to this question, when we look at the label doesn't say, it just says 500 milligrams. So it doesn't tell me 500 milligrams per milliliter. It doesn't give me any details. And so that's how you know you're dealing with this type of problem. So the order is going to be very similar what you've seen written previously, where it gives you an order. It says ANSEF 0.375 grams, intramuscular. So intramuscular tells you it's an injectable. It tells you are looking for milliliters. And at the bottom where it says part C, how many milliliters we administer, that's how that question would be asked. Part A, part B probably wouldn't be on a typical question. You'd get this label and then how many milliliters would you administer given the order. So when you have a question like this and it tells you the strength, but it doesn't tell you the concentration, like the strength per milliliter, you have to do some digging. And so what you're going to do is when you see questions like this, you're going to need to look at the instructions labeled on the side there. So you're going to look where it tells you usual adult dosage, then it says for intramuscular administration. It tells you to add 2 milliliters of sterile water, shake well, withdraw the entire contents, and that'll give you a total approximate volume of 2.2 milliliters. Now, believe it or not, we don't need any of those volumes because what we're looking for is what's right next to that 2.2 milliliters, which is the 225 milligrams per milliliter. That is the strength or the concentration for this type of medication. So once you find that, then it's just typical stuff. Take your order of the 375 milligrams. Again, I just converted grams to milligrams over my available, 225 milligrams times my quantity. And then when I round my answer, I get 1.7 milliliters. So it's not definitive whether or not you'll see a question like this, but I would not be doing my due diligence if I didn't at least show it to you, just to be on the safe side. All right. So if you have any questions, go ahead and look through the practice set. It's the same practice set that you should have received, but it's also this. I have them listed on the OneDrive folder, and then just like I said, type in the chat if you have any questions, or just talk.
APTT per minutes. If we get an answer that is like, for example, 36.7, do we round it to 37 or we leave it to 36.7?
So you can't give somebody a partial drop. So you have to round it to the nearest whole drop.
Okay.
Yep, good question.
And then can we do the Heparin protocol again, just to remind us the steps?
Sure. So I did one of these earlier. And so I think I may have changed the, let's just see if I did. Patient's weight. Yeah. All right, so let's just go through this, what I did earlier. So we'll just use the same. And then let me clear out my work. Maybe I'll change the weight again. Just for fun. Sorry for all this, guys. Give me a second. So remember, when you do the Heparin protocol, even though I have 4 questions listed, your questions are going to be different. Okay, they're going to be it's either going to be A and B only or C1 and C2 only. So what I'm going to do is I'm going to make a separate question here. I shouldn't have deleted all that stuff then, but that's okay. It's be all right. So what I'm going to do is I'm going to grab the information that I need. And then I'm going to just create a separate type of question. Just give me just 1 second. I want to get rid of my highlighting here. Try to at least. Okay, so you might see a question that's very similar how it's written here, where it'll give you some information, and then it'll ask you to answer 2 questions. Calculate the number of milliliters. So I will just keep it at A and B. And calculate the number of the heparin drip, and then it'll give you all the details here. So it'll give you a patient's weight. So I'm going to change this. Let's just do 185 pounds. But everything else will be the same. You're available. Technically is this. Your order is more so the protocol. And we're just going to use the information from the order and the available to answer the questions of bolus and IV drip. And then we can create a separate question that is basically going to use the same information, but then introduce the APTT data. So I'll do a separate thing for that as well. So let's go ahead and do this. Step 1, we need to convert the patient's weight in pounds to kilograms. So 185 divided by 2.2, and I'm going to get 84.09. So I'm just going to round that to 84.1 kilograms. Okay. So I rounded that. If you leave it the same, if you just leave it in your calculation, you should end up with the same answer. But so typically what I've been taught is that when we're dealing with the weight-based calculations, because it's a separate, calculation, it's usually fairly safe to just round to the nearest tenth because the number is so much bigger than 1. You're talking about 84 as opposed to, like, if this were like 8.4, then it might make more of a difference in your final answer. But for this, it won't. All right, so I'm going to take my patient's weight, 84.1 kilograms. And I'm going to multiply by my order, which is the 80 units per kilogram. And then I'm going to get 84.1 times 80. And that'll give me 6,728 units. I don't want units, I want milliliters. So I need to find a way to convert units to milliliters. And what I'm going to do is I'm going to look at my bolus dosage strength, 1,000 units, 1 milliliter. And so I'm going to get an answer of, and I'm going to round it to nearest tenth, 6.7 milliliters. All right, part B, same thing, same patient, same weight, but this time I'm going to find out what the flow rate is. And so it tells me the order says to start them at 18 units per kilogram per hour. So 18 units, kilogram hour. So I'm going to take that 84.1 times 18, and I'm going to get 1,513.8. And that's units per hour. Don't worry, we're going to get rid of that big number here in just a second. I don't want units per hour, I want milliliters per hour. So this is where you've already done this a couple of times throughout the practice set. Anytime you've converted units per hour to milliliters per hour, that's exactly what we're doing here. And in order to do that, I need to use what I have in my IVs. So I want milliliters. I want to get rid of units. 25,250. And then you're going to get 15.1 milliliters per hour. So, and you technically get 15.138, but you're going to round it to the nearest tenth. Your final answer rounds to the nearest tenth. The reason I mentioned earlier, like if I left that at 84.090909, like just left it at that, I'm going to get to the same answer. You can always go back and double check. Again, it's because the number's so big. The decimal shouldn't matter. So that would be how you would do like a standard heparin protocol if it was written like this. And then you might see a separate version. So I'm going to see if I can calculate. I'm going to grab all this stuff again, the same stuff, and try and create another question. There we go. Oh, good. It copied everything. Perfect. All right. Let me get rid of these other things because I'm going to make a separate type of question. I'm just changing this up a little bit just because sometimes you might see these listed a little bit differently than how I've listed them. Okay. So let's say there's a separate piece of information that we have a new APTT listed here. So let's just say after 6 hours, patient's APTT is, let me just see what we have as examples here. Yeah, we'll just keep it at, we'll just say 40 seconds. 40 seconds. Then your order would be to rebolus sorry. So rebolus with 40 units and then to increase the rate by 2 units per kilogram per hour. Sorry for all this, guys, in real time. And then, oh, I put this in the wrong section, didn't I? Son of a gun. Trying to be fun. Sorry, guys. Okay. There we go. I promise there's a method to my madness here. All right. So we still have our same available. The only thing now that's different is the order, right? So we're still going to answer the same questions. Questions being calculating the new bolus and then calculating the change in infusion rate. So let's just do a different weight too, just to add some fun. 196 pounds. So 196 divided by 2.2 gives me now 89.1 kilograms. Okay. So first thing is bolus. So we're doing a rebolus, right? So it doesn't really matter if it's bolus or rebolus. We're still doing the same things. I've just changed up the questions here, which is why it's what we're doing. So I'm going to take the same patient, or this is now a different patient actually, but 89.1 kilograms. And then I'm just going to follow the order. It tells me to do 40 units per kilogram this time. So 89.1 times 40 gives me 3,563. And then it says 0.63 repeating. So I'll just put that there. Just like previous, I don't want units, I want milliliters. I'm still going to use my bolus dosage strength of 1,000 units per milliliter. And that's going to give me 3.6 milliliters. Because I'm rounding up. I would get 3.56, and I would round it up to 3.6. And then for the new infusion rate, remember we started, so the initial one was 18 units per kilogram per hour. And we're going to increase it by 2. So the new becomes 20 units per kilogram per hour, just so you know where that's coming from. So I'm still basing it off of the heparin protocol. I'm just giving you some different examples, because this could be how the question might get asked. It might just jump right to the patient's already been on the protocol, and then this is what's next. So 89.1, 20 units per kilogram per hour. So 89.1 times 20 gives me 1,782 units per hour. Again, I'm going to use my same available. It's the same IV that they've already been connected to, which was that 25,000 units and 250 ml. And then you're going to get 17.8 milliliters per hour. So I hope that's helpful, just giving you some different examples. And then you can see how the setup is the same. The only thing that's different is, you know, the patient's weight. It's really the only thing that's different. The setup obviously is pretty much the same.
I had another question. For number 15, 15 is fairly easy, but for example, if it would, instead of being 3.5, if it was like 3.3, how would we make that into minutes?
Oh, to calculate the number of hours and minutes.
Yeah.
So you're saying if like it were, instead of if it being in a half hour, if it was like something different, is that what you're asking me?
Yeah, exactly.
Okay, so give me 1 second. I can do that. All right, so in this hypothetical situation, let's just change some of the factors up. Let's make this 200 cc's, and it's infusing at 125. I don't know if this is going to work out yet, so just bear with me, but it should work out the way you're asking me. All right, so if I set this up, I'm going to get 200 divided by 125, and that's going to give me 1.6. So that'll actually work out. Okay, so 1.6 hours. Now, you can find out what the minutes are in a couple different ways. So I can take that 0.6 times 60, and my answer would be 1 hour, 36 minutes. I think there's an easier way than what I just showed you there. And all I just, if you didn't hear what I said, I took 0.6 and I multiplied it by 60. Okay, and that's where I get 36 from. The other way that I would set this up when I know that it's, or if I find out that it's not an even number, or if it's not 1.5 or 1.25, I'm going to, instead of saying 200, instead of saying the 125 milliliters per hour, I'm going to actually say 1 hour, which is 60 minutes, and then 125 milliliters. And then I would just I'd get a real big number that's in minutes. So it'd be 200 times 60 divided by 125. And that'll give me 96 minutes. And then what I would do is I would subtract 60 minutes, which is equal to 1 hour. And then what do I have left? The 36 minutes. right? So 96 minutes is the same thing as 1 hour and 36 minutes. I don't anticipate you'll have a question like that, but now you know how to do it.
Thanks.
You're welcome. Yes, so what I'm showing you here, this is on the OneDrive or the SharePoint. So in the link that you got sent out for the Zoom link, it says click here for practice tests. When you click on that link, go to Allegheny, then go to Nursing 240, and then you'll see it listed as 23 Fall Nursing 240 practice, and you'll see it listed in there.
Thank you.
You're welcome. $20?
Yeah.
Okay. I'm assuming that's the syringe. Yeah. So this was asked earlier today, and I'll just leave up what I have. So keep in mind the when you're labeling this, the first thing I would highly recommend is just write out, you know, solution amount to be drawn up first, 22 units regular, total 58 units total. Make sure you write it out on your test. That way there's no doubt that you know exactly what you're doing. Then
They don't care. They want you to, it's that they got me, whatever, I passed, but they flunked me on this question because the labeling was not how they wanted it.
so the labeling should be how I have it written here, where you put a mark at the total, and then the regular insulin is supposed to go closest to the total mark. So basically all I'm doing is subtracting 22 from the total, which is the same number as this 36. And so, and I've even added a little bit more detail. Like you could see I added like NPH is 0 to 36, the regulars at the 22 units. So I know that some of the instructors have given some I guess some grief in the past. I'm hoping that honestly this question is not a math question, so I'm always hopeful that they'll just stop asking it, but it's been on there, it continues to be on there, so that's why I continue to show you, but how I have it listed is the correct way. And then I'll even show you if you ever need to challenge it. I'm gonna share with you. This is a image from a textbook, and it shows you the proper way. And this is also in the share folder. So it's just called mixing two types of insulin. So you see how the graphic here, it shows you the total amount in this example is 40. The 10 units of regular is between 30 and 40. And then the 30 units of the Humulin N is between 0 and 30. So technically this is a better way to mark it instead of just two arrows. But and honestly, if you write it like this, you should be without a doubt 100% correct. Do you remember why you missed this particular problem?
It was something with the arrows. They didn't like where I put them, even though I labeled exactly where NPH. It was a bad professor, let's put it that way.
Okay. Well, I will say if you label it like I've shown, it should be okay. Yeah, and if I was well, I'm not even gonna change it. I'm just gonna leave it as it is.
For the question number 6, it gives us the same amount of time, like every 4 hours. what if is there like every 6 hours, like not the same amount of time?
It won't matter because it's always going to be relative to, well, first of all, it should always be the same. It should always be 4 hours. But it won't matter because it's just based off of the total output and then whatever the replacement scenario is. So it doesn't like, so if it said to replace it every 4 hours and then after 6 hours, you would still calculate it the same way.
Oh, okay, thank you.
You're welcome. Yeah, you can't assume that if like they voided 600 milliliters in 4 hours, but if I said it was 200 milliliters in 2 hours, you can't assume that 4 hours was another 200 milliliters. You just can't do that. So you just have to use the information that is available. So the 4 hours is kind of a distractor, that it doesn't have any weight on how you answer this question.
Right, because maybe like, you know, it could be less amount of urine output, right?
Correct. You could have all that voiding occurring in the last 5 minutes of, you know, whenever they're going to the bathroom. So it's not continuous. So it's basically like when you're evaluating it. So you're looking at their catheter and you see that, oh, okay, there's 800 milliliters in the catheter. So we know that they voided that much. We need to replace, 40 milliliters for every 100 milliliters that was voided. And then that's what you're basing your calculation off of. I'm just making up numbers. So I'm not reading anything if you're wondering where I'm coming up with those numbers.
In protocol.
Go ahead. What's your question?
It's like number B, like we did the 89 kg
Yes.
times 20 units. So where did that come from? The 20 units I don't see. I
Okay.
saw 40 units, but
So remember, I just copied and pasted the question. So remember, our original was 18 units per kilogram per hour, right? Because it says it. I deleted it here, but it said it in the original, right? 18 units per kilogram per hour.
Oh, okay.
And then it told us to increase the rate by 2 units per kilogram per hour. So 18 plus 2 is where 20 comes from.
Oh, okay, got it.
And then on your test, the way it will probably be presented is like this, where you're seeing all this, like these little subsets here. So you just follow what it says to do in the particular thing. So if it tells you 40 seconds, if it tells you 50 seconds, if it tells you 80 seconds, you just do what it says to do in these things.
Okay.
Good question.
Thank you.
You're welcome. All right, so let me pull up 17. So is this the 150 mil packed red blood cells?
Yeah.
Okay. All right, so keep in mind, anytime we're doing a drop rate question, you need 2 pieces of information. Now, I had this conversation with somebody because they were saying like, can't I just do dimensional analysis? And I'm like, well, yeah, that's what this is. I just simplify it by saying you need 2 pieces of information. You need your flow rate and you need your drop factor. That's what I meant to write. Drop factor. Okay, so you need those 2 pieces of information. So what is my flow rate? So it tells me 150 milliliters packed red blood cells within 2 hours. Drop factor is 15. So what is my flow rate? So my flow rate is 150 milliliters. And then it says 2 hours. I'm going to encourage you to do what I'm going to do now is I'm going to just right off the bat convert hours to minutes. And I'm going to say 150 milliliters, 120 minutes. This way I don't have to worry about doing a separate step of dividing by 60. I've already taken care of the converting hours to minutes. Then I just multiply by the drop factor. You know you set it up correctly because you're left with drops per minute. And you just do 150 times 15. Divided by 120. And you're going to get 18.75. But remember, I can't give somebody a partial drop. So I need to round that up to 19 drops per minute.
Is 18, if there is 18.74, then just I put the 18 ml per hour, 18 GT per minute.
Will you round to the nearest whole? So if it's 18.75, you're going to round it up to 19.
Yeah, but 18, if there is answer is 18.64.
Still rounded to 19.
Okay, thank
Yeah,
you.
0.5 and above, round up. 0.4 and below, don't round up. Just leave it at the whole number. So if it was 18.45, it would be 18.